hand to mind designing products for math instruction. Math instruction. Andrea, Amy B, Amy Neidert, and I all have heard Brittany speak several times, and she's become my math hero. I told her math knowledge is just huge, and she's a wealth of knowledge for us. So we have purchased the Daily Math Fluency from Hand to Mind, and so she's going to present basically the rationale behind that, and then we'll get our hands on the materials at the very end. So I'm going to let you take it away.
Thank you very much. So thank y'all very much for being here this afternoon for this training for Daily Math Fluency. Just a little bit more about myself, just so that you kind of know where I'm coming from. Yes, I was the elementary math consultant at Region 10 for 6 years, and recently have transitioned. But before that, I was a classroom teacher. So I worked in grades 1 through 4, and then my very last year in the classroom, I became a 7th grade math teacher. I wanted change and challenge in my life, and I definitely got both. So I went from being a 2nd grade teacher to being a 7th grade math teacher. A lot of my reasoning for doing that is because I wanted to see what we were doing in elementary. How does that go into middle school? Because I always have hearing, kids don't know this, they don't know this. And I know at elementary, we're all working really hard for our kids to know things. So I'm trying to figure out where's that disconnect and things like that. So I learned a lot by doing that. And some of those conversations might come out in this conversation. But at Region 10, I was still had the opportunity to still be in classrooms, work with teachers, and get into those classrooms and work with students as well. And this was just one of those ideas that came kind of about from that, from doing presentations with teachers and things like that, is this idea behind Daily Math Fluency. So what we're going to do today is really experience a lot of the math, and like Tony said, the rationale behind this, and then we'll get into the actual product. So my hope for you is that by the end, you will have the product in your hand, and you will be able to go back to your classroom starting this fall and be able to implement that successfully. But what we're going to do, what we're going to cover this afternoon is, the first thing we're going to cover is, what is numeracy? So we hear that word a lot. We hear like, oh, this kid has numeracy, this kid doesn't. Like, what does that actually mean? Because I want us to make sure we're clear and we're all on the same page of what we're considering what numeracy is. So we're going to talk a little bit about that. We're going to talk about how kids develop mathematical reasoning, because we want kids to reason about mathematics, but how is that actually developed? What stages do kids go through? And y'all get the opportunity to get kids when they're fresh, when they're just coming out, and so you're really laying those foundations. And so we want you to see like why that foundation you're laying is so important and how that builds into other grade levels. And then we're going to talk about 2 routines that we can do in our classroom to really help build mathematical fluency. And those routines are going to be using number strings and math talks. So when we get to that part, we're really going to be experiencing a number string and a math talk from the way that we might want our students to experience that. And then the last thing is we're going to look at how does daily math fluency play a role in this idea of helping kids with this idea of numeracy and with their fluency. Okay? So we're going to get started with this idea of numeracy. So the first thing I want you to do at your table is, because I know you're coming to the table with some ideas, I want you just to talk with either your shoulder buddy, or if you don't have a shoulder buddy, y'all talk as a table. These are pretty small groups. Y'all can probably talk as a table group. But really, when you hear that word, what comes to mind? So when you hear the word numeracy, what are you thinking about? So if you'll take a moment to talk with your tables. y'all know how to bring it right back to what we're talking about. Okay, if you will finish the sentence you're on. As I walked around, I peered into your conversations a little bit and kind of listened in just to kind of hear some of those themes that you were saying. I heard someone saying, it's that they understand two in multiple forms. They not only understand two in the written form, but they understand it in a picture, they understand it using a 5-frame, using a 10-frame. So really being able to see those numbers in different ways, not just the actual abstract written number 2, right? Or just knowing this is 1 versus this is 2, and what is the difference in those types of things. So those are all really good ideas of what is numeracy. I'm going to give you a definition that we're going to kind of work off today, and hopefully with this definition we can see how what we're doing is really helping kids develop this idea of numeracy. But it's this definition right here, and it's really about the ability to use those mathematical relationships to reason about numbers and numerical concepts. So they're really thinking about how are numbers related. So just like what you said, like if you see 2 versus 1, like what is different about that? And understanding this idea of 1 more and 1 less. That's a relationship between 2 and 1. Or seeing those numbers in those different forms. So seeing a number in a 5-frame, 2, versus seeing the number 2 just kind of scattered out or in the written 2. Those are some different types of relationships that we can kind of see. But numeracy is more than just that. That's kind of the broad term of it, but there's definitely components to numeracy. So when we say this kid has numeracy and this kid doesn't, there's different components that kid has. So here's some components to think about. When kids are flexible, that is a piece of numeracy. So they don't just know one way to either compute, or they don't just have one way to think about that number. They can see that number is, they need 3 more to get to 5, or it's 3 less. That is being flexible in their thinking. Efficiency is really an important piece. I can tell you, starting in kindergarten, kids are not real efficient in how they're getting to their answers. And that is perfectly fine. That is where we start, right? But the idea is, it's not where we end. What they're coming to us with is not, even if they can get right answers, that's not enough. We really want to hone in on this idea of getting kids to be efficient in their thinking. We also think very importantly that accuracy is important. We don't want them just skipping around and going 1, 2, 5, 7, like we want them to be accurate, right? That is a part of numeracy. But what I will say is sometimes we get too focused on accuracy and we're more about getting the answer instead of talking about the process. But I don't want to lose sight that accuracy really is important. But don't forget that how they're getting to that is also very important as well. And then here's this word creativity. And I have my friend in here. What is his name? Brian. So Brian, I need you, I know you were only working on the technology part of this for us. But Brian said something to me this morning. He said, oh, this is math. Nope. I'm more of the creative type. You said something like, I'm more of the creative.
I said math and fluency do not go in the same.
Yeah, and you said math and fluency do not go in the same thing. And you said, I'm more of a creative type person, right? Well, it sounds like you may opportunity to be creative in how they see that and not just think my way is the way to do it. Okay? So we're trying to change that so creativity can be a part of mathematics. So those students who are really creative have that opportunity to shine in this area. Algorithms are also very important in K1. Y'all don't get into a lot of different algorithms, that really starts more into our second grade. But I don't want us to lose sight that algorithms aren't important. So I want you to recognize that in second grade we do introduce the traditional algorithm. And what I told the second grade teachers is, I want kids to know when to use the algorithm. When is it appropriate to use the algorithm, and when is it more appropriate to use a different strategy? That, when they have numeracy, they can depict on when those happens. And my rule of thumb is, when you look at numbers and you can't see any relationships with those numbers, it's time to pull out a traditional algorithm. When you don't see how those numbers relate to each other, now it's time to work on using the traditional algorithm. But if not, if there's a way, let me give you an example, 99 plus 37. I don't really want kids lining that up in their head, trying to do 99 plus 37. I want them to see the relationship between 99 and 100, right? And so recognizing that that's just 136 or 136, because that's what it is when I do 99 plus 37. But sometimes we get so lost in just the algorithm that we're just telling kids to stack the numbers and do it. There's a lot more efficient way than doing it that way. So I want them to recognize when is it appropriate and when is it not. And then this idea of mental math. So when I have this word mental math, and I just actually was down in San Antonio at camps and I was doing some presentations and we were talking about this word mental math. As soon as I said that, they were like, yeah, that's math that you do all in your head. And for the most part, I would agree that's normally how we do it, but I think it's more than that. I think mental math is actually using your head to reason about numbers. That's what mental math is. And so in K1, yes, kids can do a lot of the math in their head, but when they get older, they have a lot larger numbers that they're working with and manipulating. They might need to keep track of their mental steps on paper. Still mental math, as long as they are thinking and reasoning about the numbers. Okay? And then this last word is speed. So when I think about speed in numeracy, I want kids to have quick recall for sure. But really what I'm asking kids to be able to do this speed is more about the ability to choose a strategy quickly. So we help kids construct a lot of different strategies. I don't want them to get bogged down in all those different ways and not be able to get to their answer quickly. So I want to give opportunities where kids have opportunities to look at numbers and be able to choose a strategy quickly. So that's where we're wanting to get. K1 is going to really be laying that foundation. That's what you're going to be doing. And in second grade is going to start working on that foundation that you're laying and start helping kids be able to choose those strategies really quickly and be able to get them really efficient in this area. I love this quote right here. It's what I truly believe about numeracy, is that numeracy can't be taught, it has to be caught. And that's by Christina Toldevold. She is the recovering traditionalist. She has a blog called Building Math Minds. She has a big summit coming up where there's a lot of different speakers. But I think that is really important that we understand. We cannot teach numeracy, meaning I cannot impose my way on my students. I have to figure out a way, what kind of activities, lessons can I do in my classroom to help kids catch numeracy? How can I help them construct it themselves? I want them to see it. I want them to take ownership of it so that they latch onto it and they truly understand what's going on. So I'm hoping by the end today, we're going to come back to this definition quite a bit. I want us to see, how do we help kids catch numeracy instead of just trying to pour it into them, okay? I know you are not in K1 going to see these types of numbers, but because we are adults, I just want us to do a little started, okay? And it's this idea of 34 plus 98. And so what I want you to do is, I'm going to push you to think and reason about the numbers. So if you have a go-to strategy, I want you just to look at those numbers and see if you can think of another way to do that, okay? So think and reason about that. I'm going to give you a little bit of time, think time by yourself. When you see everybody at your table is finished, y'all can talk amongst yourselves about how you thought and reasoned about those numbers. Okay. Finish the sentence you're on. So for this part, I'm not going to make anybody, talk to us and tell us exactly how they did. Because I came around and I listened and I heard some of you. But I heard some people in here for 34 plus 98. So I want you to see if this is your way. I heard somebody say, well, I did 30 plus 90. And then I knew that was 120, and then the 4 plus the 8 is 12, and so then I got 132. How many of you decomposed the 34 into 30 and 4 and 90 and 8? How many of you did that? Couple of different, there you go. Okay, yeah, that's awesome. Okay, so they really were thinking about place value. Really thinking about those numbers in their place values. But then I had some people in here who thought about 98, they noticed something about 98. And they noticed that 98 was really close to 100. So there's a couple of different ways that people might have chosen to do this. This is one way that I heard. They said, well, I knew 98 was close to 100, and it was just 2 away, so I took the 2 from the 34, right? So I had 32, so 100 plus 32 is 132. Nice. Or some people were like, well, I just thought of 34 plus 100. I know that's 134, and then I just adjusted 2, so it's just 132. So it sounds similar, but it's a little bit different, okay? And then some of you in here were like, and I heard this comment, well, that's not how I did it first. The way I did it first was I lined them up in my head, and I did the ones, and then I went to the tens, and that is perfectly fine depending on where you are in your own numeracy, okay? So, to get us to think more flexibly and things like that, sometimes that's what's difficult, okay? But hopefully by the end we're going to talk about that and see why we might do that and what we can do to help our students do that. So we're going to start with this idea of how students develop mathematical reasoning. In kindergarten, y'all are definitely starting with counting. Y'all are counting everything, and that is where kids start. 4, 5. Or if you could even get them, even for a problem like 2 plus 3, they could know, oh, I can start at 3 and go 4, 5. It's a little different. I'd take any kindergartner that could do that to first grade. That would, your first grade teachers would be like, yeah, here y'all. You're like, yeah. If that's where they started, right? So that's like our goal in kindergarten. Let's get them to be able to count on, either from the smaller number, or even better if you can get them to count on the larger number. We want to do things that are going to promote that. But because in first grade, they're going to work on counting because they're going to take our kindergartners and they're going to really help them, nudge them to be able to count on what we just kind of heard. But more importantly, we're going to help them think additively in first grade, which means we've had all of kindergarten to really think about numbers as 1, 1, 1, 1, 1. But now in first grade, we're going to do a little bit of that, but we really want kids to start thinking about those numbers, not as 1, 1, 1, 1, but think about those numbers in their parts or in their chunks. So now I need a kid in first grade, now not just to think of 7 as 1, 2, 3, 4, 5, 6, 7, but think of 7 as 5 and 2, or 4 and 3. So all those different ways, or 6 and 1. They need to be able to think about those numbers in those parts. Kindergarten actually does a little bit of that for us when they're decomposing 10, right? They're working on that understanding. But we're not necessarily using that understanding for addition problems or subtraction problems. In first grade, we're really starting to work on strategies that are based on that additive thinking. So, first grade, if a first grader encounters the problem 8 plus 7, thinking additively, they could think 8 and 2 is 10, and 5 more is 15. Or a first grader could think 8 plus 7 is 15 because 7 and 7 is 14 and 1 more is 15. Or 8 and 8 is 16 minus 1 is 15. That's additive thinking. That's now not thinking about the numbers as 1, 1, 1, 1, but now thinking about the numbers in their parts. Because for 8 and 2 is 10 and 5 more is 15, they're thinking of 7 as 2 and 5. Or for 7 plus 7 is 14 and 1 more, they're thinking of 8 as 7 and 1. And they're reassociating those. So that's making kids now think about the numbers in their parts. So why would that be important? Because in second grade, when second grade teachers get them, their job is to take what you've laid, that foundation you've laid, and now they're expected to get those basic facts to automaticity. Meaning, they need to be able to say 8 plus 7, 15. 7 plus whatever, 6, 13. They have to be able to say that quickly. But what we want to make sure is that they have a strategy attached to that made them think in those parts. Because by third grade, we're expecting kids to think multiplicatively. Which means, for a problem like 7 times 6, we're expecting kids to think 7 times 6 is 42. A way to think about it, 6 times 6 is 36 plus another group of 6. 7 times 5 is 35 plus another group of 7. It's really hard to get a third grader to think that way if they are for 8 plus 7 going 8, 9, 10, 11, 12, 13, 14, 15. Because we're now expecting them to take numbers like factors and split those into groups. And if they haven't been doing that with addition and thinking additively, that's really difficult for them to do multiplicity. It's not impossible, but it's very difficult. So all of these, the way we develop, it all builds upon each other. Because then when they get to middle school, we expect them to think proportionally. Well, it's really hard to think proportionally if they haven't been thinking multiplicatively. And then the very end is what's called functional reasoning, which is when we get into algebra. And if you think about our struggles in algebra as a society, it's not just, it's not just a district, it's a society. Most of the reasons why our kids either go one way or another in math is to a lot of kids in middle school, and this is what I saw, were stuck all the way back in counting. So for 7 times 6, a 7th grader would do 7 plus 7 plus 7 plus 7 plus 7 to get it. And the only fact they would know in there would be 7 plus 7, and they would know that's 14. And after that, they go 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. That's how they got 7 times 6. And I'm not talking about one student. I'm talking a majority of the students. So we have middle schoolers who, if you think about where they should be, are stuck in counting strategies. So that's the great thing about K-1. All we're asking is lay that good foundation at that kindergarten. First grade's like, yeah, if y'all kindergartners teachers can get our kids to count on and really help them understand this idea of composing and decomposing, then we can take them from there. We can work on a little bit more on counting on, but we're really going to focus more on additive thinking so we can help our 2nd grade teachers really reinforce that idea and help them get to that automaticity. Okay? So that's really where y'all kind of live. But I wanted you to understand how everything develops and how that foundation is so important. And this is research done by Pam Harris, who's an author of quite a few different books, but she's done, her book is called Middle School and High School Numeracy in middle school and high school, but she's done a lot of work in the elementary realm as well. So, when we think about math fluency, so we've talked about numeracy, but when we think about being fluent in math, we are making sure that kids are accurate, efficient, and flexible. And they know when to use one strategy over another. That is having mathematical fluency, okay? And we want kids, the reason why we want kids to be mathematically fluent, we want them to be flexible in those things, is because we want them to be the thinkers. We want them to construct the knowledge. We want them to create the relationships that they understand. So, what we're going to do is we're going to talk about building mathematical fluency. But before we do that, we have to actually do a little bit of a reflection piece. And that reflection piece is about your math instruction when you were growing up. Okay? Because a lot of times we take the way that we learned and we sometimes put that onto our own students. So we want to think about that. Okay? Think about where we're coming from as teachers, as math learners. So, I want you to think about you learning your math facts a long time ago, okay? Or for some of you, not as long as for me, okay? Some of you maybe not too long ago. But go back to when you learned your math facts. And I want you to think about who you are as a math fact learner. Were you someone who had strong memory skills and just memorized your facts? Were you someone who struggled to remember your facts and connect meanings for facts? Or were you someone who just intuitively used knowledge of one fact to help you solve another fact? So I want you to think of who you are, and I want you to share at your table so that you know how each other learned their facts. So just take a moment to do that. right? But the ones are, you had strong memory skills, so it was really easy for you to memorize your facts. Like you knew your facts because you memorized them. But there are people in this room, as I was walking around, that said, yeah, I was told to memorize my facts, but I really struggled with my facts because I didn't understand what was going on. I couldn't make any connections. And maybe you don't have that necessarily, those strong memory skills. And that's okay, because that's a lot of us, a lot of our students don't have strong memory skills. They need to understand what's going on before they can make those connections, before they can get to those answers. But I know for sure I was definitely a 1. I had strong memory skills. I looked as if I was a really good math student, but it was all because all I did was memorize what my teacher told me. Okay? So, we're going to do a little experiment. I'm going to flash something up here on the screen. Okay? So, not that. Because last time I learned that people were trying to read that. Okay, so that's up there. So we're going to do a little experiment though, and I'm going to flash something on the screen. And your job is to tell me after I flash it up there what it says. Are y'all ready? What do y'all think it says? Tell each other what you think you saw. That was good. Some small boys cabin. I like that. Okay. As I listen to y'all, I hear jump, small boy, maybe in a cabin, like, I don't, like, something like that. Okay, y'all ready for the next one? Okay. What'd that say? Oh my gosh, y'all were able to read that one? That, what, because it what?
It made sense.
Oh, it made sense. Okay, so what I want you to do is I want you to relate what you just experienced. How does this relate to math facts? So take a moment, and I want you to think about that. Think about why, what made it so difficult, to why, how it made it easier.
I learned, yeah, I expected that I was reading a whole little bit real quick because we used our yeah, it was the same word.
Okay, if you will finish the sentence you're on. How did what you just experienced with those words relate to math facts? What y'all talk about? I heard y'all saying stuff. So something out loud. I heard y'all talking, and y'all were talking about the right thing. You were talking about what you're going to do, or what you've been doing this summer.
If you understand it, you can figure it out quicker.
Oh.
If you don't understand it, it's harder for you to put things together.
Okay. So if you understand it, it's easier to figure out, but it's harder to put things together that don't quite make a lot of sense to you. Nice, yes.
My parents, they were just blown away by me, Pearson, and they're just blown away, by some of this. And so the way I explained it to them was like, we can tell time, but if you can take that cloth and take it apart, put it back together again, then you understand, why the mechanism of the clock, why it works. And, okay, they understood
Yeah.
that, but it really, parents are really blown away by some of this math that we put out.
Yeah. No, and rightfully so, because I can tell you, like, I a strong memory. I know 8 plus 7 is 15 because there's an 8, there's a 7, and on the back there's a 15. All from me visualizing what that card looked like. There was no thinking, there was no reasoning about what was going on. Those numbers were isolated numbers that went together somehow. That's what it was. I didn't think, I didn't reason about those numbers. So, but because I had a good memory, that worked for me for that moment in my mathematics instruction. That doesn't mean it did any help for me when I got into algebra and geometry and things like that, because I didn't know how those numbers were working together. I didn't understand those pieces. For those kids that couldn't memorize, those twos, those strugglers, when they looked at 8, 7, and 15, it made no sense whatsoever. They could not figure out how they connected together. They could not figure out what the relationships between 8 and 7 were. So they struggled a lot to get to that answer and probably reverted to something that looked like this. Okay, 8. I need to go 1, 2, 8. Okay, 7, 1, 2, 3, 4, 5, 6, 7. Okay, 1, 2, 3. That's what they did. And that's why it took so long for them to figure out their facts. They understood addition. I'm not saying they don't understand addition. They understand the concept of putting something together. But they don't understand how 8 and 7 are related to each other. That's what they don't get. So I can give you an example, and I probably should think more of an addition one, but I'm going to go ahead and give you all a multiplication one. 9 times 5. You would think that would be an easy fact for students because it's a 5, right? We have a lot of students who for 9 times 5 say 54 because they're just reversing it. If you think about 9 times 6 is 54, they just reverse the 4 and the 5, and so they say 54. If kids only know 9 and 6 or 9 and 5 and 45 as isolated pieces, then when they get an answer like 54, they have no idea to tell you if that answer makes sense or not. It's just what I got, right? But if a kid understands that 9 groups of 5 versus 10 groups of 5, if I know 10 groups of 5 is 50, well, what do I know about 9 groups of 5? It has to be less than that. It has to be, and it has to be 5 less. So 54 would not make sense for 9 times 5 because I know that 10 times 5 is 50. That's the relationships and the understanding that kids have to understand. To be able to understand when they get answers, why their answer makes sense and help them make those connections to that. So that's what we're doing with addition and subtraction. We're doing those same types of things with strategies that are additive strategies in those ways. So I just wanted us to keep that in the back of our head of why this is so important that our kids understand this. Okay? So the other thing is this idea of memorization versus automaticity. Even though in K and 1 y'all do not have to work towards automaticity, our second grade teachers do. And so I just want to make sure we're clear because it sounds like a lot of you had a lot of what I had was memorization. So what is the difference? Because our standards were very, they chose the word automaticity instead of the word memorization. So here is a definition of memorization. So just take a moment to look at that. When I look at that word, or that definition, what sticks out to me, and I've kind of made it obvious because I've coded it in red, but it says, so that thinking through a computation is unnecessary. The emphasis is more about the answer. It's all about just recalling that answer. That's exactly how I learned. It was just about, please just remember 8 plus 7 is 15. That's all I need you to remember. Just try to remember it. That's definition of automaticity? One of the big differences for automaticity is that it does rely on thinking. We want kids to think about the relationships in those numbers. But more importantly, when we think about automaticity, we want them to use that relationship to get to their answer. So the way we get kids to automaticity is we have them practice a strategy over and over and over until it becomes automatic. So a second grader, and this is why it's so important in first grade that we lay this foundation, and kindergarten is helping us do that, but first grade, we're helping kids see those strategies, those doubles, that get to 10. Those are important strategies because in second grade, they need to be practicing those strategies over and over and over until those facts become automatic. That's automaticity. But what I like best about this quote, because this came from a lady named Kathy Fosno, what she says here is, the issue is not whether facts should eventually be memorized, but how the memorization is achieved. So guys, we want kids to look just like how we did when we said 8 plus 7. We want them to be able to say 15 really quickly. The biggest difference is they have practiced an efficient, an additive strategy that they practice over and over and over of why 8 plus 7 is 15. Is it because 8 and 2 is 10 and 5 more is 15? Is it because 7 plus 7 is 14 and 1 more is 15? Because 8 and 8 is 16 and minus 1 is 15? Any three of those, I would not, however that kid wants to practice that. That's the one that when they see that's the relationship they see. They see the 8 as 7 and 1, or they see the 7 as 5 and 2. Whatever relationship they see, that's what I want them to practice. And I want them to practice it over and over and over until it becomes automatic and looks exactly the same way memorization does. Okay? But that's what we're trying to achieve. But we can't achieve automaticity if we don't have any strategies. And they have to be efficient strategies. We can't keep them in counting. Okay? Any questions? Okay. So, when you are thinking about fluency instruction, this is the one I know we do a fabulous job on. I know we work on the conceptual understanding, especially in K-1. We really want them to understand what is addition, that is this idea of putting things together. What is subtraction, that we can separate things so we can compare things. Those are really important pieces that we do, and we investigate that. We investigate that using strategies like counting, so either counting 3 times or counting on. And then we also work a lot on this additive thinking where we are thinking about the numbers in the chunks or in the parts, whether we're having kids compose and decompose numbers. We're doing those types of things. But we can't stop there with our students. We actually have to help kids construct strategies to help them support their understanding of how those numbers actually work together. And so that's where we are going to live today, is on the second bullet. Because I know you've got things for the top, but we're going to live. How do we get kids to construct strategies? What do we do to help them really understand how those numbers work together? And then after kids have had opportunities to construct strategies, we have to help them practice the strategies. We can't just assume because we constructed it that they're always going to use it, because guess what? The most natural thing for kids to revert to is counting. It is the most natural thing. So if we don't make a big deal about it, they're going to revert back to what's inefficient. Okay? So we're going to stay on that second bullet today. So we are going to do that through the use of 2 routines. We're going to do that through number strings, and we're going to do it through math talks. And so the easiest way that I know how to help you see what a number string is for you to experience the number string yourself. how do you see it? Okay, so how many and how do you see it? And then what we're going to do is we're going to do this series of those things. If I'm in a classroom, my kids for number strings in second grade did this. They put it over their mouth because some of you in here, we're toasters. We like to pop out our answers. And some people need to simmer just a little bit longer. They need to look at that just a little bit longer and think about that. Okay? So saying it in your classroom. I'm not going to make y'all put your thumb right here. Okay? Like, I'm not going to do that to you. And I'm probably not even going to make you do this quite yet, okay, for this number string that we're about to participate in. I really am going to flash up the picture, and I'm going to ask you how many, and I'm going to ask you how do you see it, okay? I'm going to find my, oh yeah, it's right here. Okay, so are y'all ready? So here we go. You're going to tell me how many? How many? Four. Okay. So, can someone tell me, how do you see 4? Who wants to tell me how you see 4? How do you see 4? You see 2 and 2? So, which 2 and 2?
Top and bottom, top and bottom.
Top and bottom, top and bottom. So you saw it like this. So depending what grade level you are, I could say 2 and 2 is 4. Or if I'm in first grade, I could say 2 plus 2 equals 4. I could say 2 plus 2 equals 4 in kindergarten when we've introduced those symbols, but until we've done that. Or I could choose not to write any of that and just model what you just said, 2 and 2. Okay? Did anyone see 4 a different way? You see 4 a different way other than 2 and 2?
I just saw it as 4.
Ah, so you just knew when you saw that, you just knew that was 4.
Yeah.
Yeah. So can you know that? Yeah, that's just 4. What's familiar about that for you?
Domino.
A domino. Okay, so I see those on dominoes. So that's the 4 on the dominoes. And I just know that that is 4. That is perfectly fine. And I would just circle the whole thing so you know it was 4. Anyone see it a different way?
Well, the range like a square, and then a square has 4 corners.
Oh, so you can think about these 4 corners. So I could think about, like, this is a corner, this is a corner, this is a corner, this is a corner, and there's my 4. So that's really about thinking about 4 as 1 plus 1 plus 1 plus 1. And that's 4. If I'm thinking about those individual, or if that's just something I know, then you might just say it's 4. Okay, nice. Okay, here we go. Y'all ready for the next one? How many?
6.
Ooh, 6. Okay. So, something that looks like this. So I'll go back here. How did you know it was 6? 3 and 3? So you saw, so some people are like, I saw 3. Oh, I'm just doing that myself. Is this where y'all saw 3?
Yeah.
So sorry. So 3 and 3. So 3 and 3 is 6. Did anyone see it a different way?
4 and 2.
Where is 4 and 2?
Oh, 4 in the middle and then 2.
Oh my gosh, didn't we just have 4? Didn't we just have 4?
We did.
Yeah, I think we did, right? So you're saying, I see this 4, and then I see this 2. Let me ask you about the 2. Did you see the 2 as 2? Like you just knew it was 2, or did you see it as 1 and 1?
1 and 1.
1 and 1. So you were thinking like 4, and then plus 1 plus 1. And that gets you to 6. So 4, 5, 6. So if I know this is 4, I could go 5, 6. That's nice. You can count on. I know this is 4, and I can go 5, 6. Did anyone see it a different way? Okay. Here we go. How many? 5. I was like looking up here going, is that the right one? Yes, it is. Okay, how did you see, sorry about that, how did you see 5? You just knew that was 5? Is that one of those like common structures that we just know? So you knew the whole thing, you just know that is 5. Did anyone see it a different way? Or did everyone going like, that's the way I saw it? How many of you might have a kindergarten student that says, well, I saw it 5 because 1, 2, 3, 4, 5. Did you have a kindergarten student that does that, especially at the beginning of the year? Yeah. And if they did that, I would say, oh, okay, so you saw 5 because it's 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Is that how you saw it? So I'm going to model that the way they're thinking about their 5. Okay? Y'all ready? How many? 7. Did someone see something different? Did someone see something different?
Oh, there was an extra little thingy.
No? So you thought there was 8? Okay, no. So did you think there was 8?
Yeah.
This is important, okay? So we have some people in the room who saw 7, and we have some people in the room who
Just
saw...
one.
No. In a kindergarten or first grade classroom, what do you think? Do you think they're all going to see 7?
Oh, no.
Or do you think, oh, okay. So it's okay. So I'm just going to list all those different ways that they saw it, because I'm going to write those down, okay? So, but whoever gave me the first answer, which I heard 7 first, I'm going to go with that first, but if I would have heard 8 first, I would have went with 8 first. It would not have mattered, okay? I don't care if it's right or wrong. That's just my rule of thumb, okay? So, how did you know that's 7? How did you know that was 7? 5 and 2? Oh, that's interesting. Why did you go to 5 and 2? Can you tell us more?
Because there's 5 and then 2 more.
Did we have 5 a while ago?
Yes.
Was this one 5? So I knew this was 5 and this is 2? How does that help you to know that? How does that help you to know 7 as 5 and 2? How did that help you to know that was 7? To see it as 5 and 2?
Because I can count on.
Oh, who said that?
Count on.
You can count on? So talk, what does that sound like then?
5, 6, 7.
So to see if I can go 5, 6, 7. That's really a nice way of thinking about 7. I know 5 and then I can go 6, 7. So y'all saw it as 5 and 2 and that's 7, but to get that 7, you did 5, 6, 7. Yeah, because that's really kind of nice because I know that and then I can just nice. Anything else? Anybody have anything different? Okay.
So how would you approach if they got it wrong, if it worked?
Great question.
They said 8.
Yeah, they said 8. Yeah. So what I would have done is I would have said, okay, so tell me how you see 8.
Mm-hmm.
They're going to tell me how they see 8. 9 times out of 10, they're going to fix it.
Okay.
And then that one other time that they don't fix it, that's okay. I'm going to question them.
Okay.
I'm just going to ask them some questions. So talk to me more. Like, and I might even have to have them come up and show me. So I want you to count that for me. So they might have to count it for me.
Okay.
And that's okay. Okay? Good question. Y'all ready for the next one? How many? 9. Okay. And I did really quick. In a classroom, it would not be that quick. Quick images are 30 seconds. But y'all already don't, so y'all get to get them a little quicker than that. Okay? So you saw something that looked like this? Something that looked like that? How'd you get 9? Y'all said there's 9? How's there 9? How do you see 9? 5 plus 4? So 5 plus 4 is the same thing as 9? How does it help you see 9 as 5 and 4? How does it help you to see it like that? Do you want to see 9 with scattered objects? Or do you want to see 9 arranged like this? Why? It's organized, right? So how does it help you know this is 9? I need you to revert back to your kindergarten and first grade years, because I know y'all know it's 9, because y'all know 5 plus 4. You got kindergartners in your classroom that do not know 5 plus 4. You've got first graders who do not know 5 plus 4. So how does it help for them to see a 5 and then see a 4? How does that help them get get to 9.
They can count all the, for those that just started, they can count all the circles.
They can count all the circles.
With their fingers.
So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Does that help them be arranged then? Does that really help them? Does it help them know that 9 is 5 and 4 if they're going to count everything? Not necessarily, right? So that's a good idea that you will understand what your kids are thinking. If when you ask them, how does that help you? And they say, because it's 1, 2, 3, 4, 5, 6, 7, 8, 9, it's not helping them. It's not helping them see 9 as 5 and 4 if they're counting everything. So how else could it help you to know it's 5 and 4? Grab 5 and go 6, 7, 8, 9. That's exactly right. That's when it helps you. It helps you know, because I've arranged it into two things, whether you grabbed 4 or whether you grabbed 5, but knowing that I know something, I know this, and then I can just count on from there. Okay? Those are things that you're wanting to hear your students be able to tell you to help you get to this idea. So I can start here at 5. I know that. And then I just went 6, 7, 8, 9. That gets me to 9. Okay? So, what y'all just experienced was a number string. It went 4, and then it went 4 and 2. I had to find the person in this room who saw this 1 as 4 in the middle, 1 and 1. I agree that seeing that as 3 and 3 is a really nice way of seeing 6, not what I was going for. But I went ahead and modeled it because it's still a nice way to see 6 as 3 and 3. But I had to find the person in here who did the 4 and 2. Because they could go, oh, I know that's 4, and then that's just 5, 6. And I brought that out. Help you bring that out. Then we went to 5. And then I went 5 and 2. I had to find the person in the room who saw 7 as 5 and 2. And then I added the extra question of how does it help you see it as 5 and 2? Like, how does that help you? Because again, if they're counting everything, then it's really not helping them see these numbers in these chunks. We want them to see the numbers in the chunks so they have a starting point of a number and they can count on and see those ideas. And then 5 and 4 was the next one. Because now they could even build on from there. Well, we could have found somebody who said, I saw 7. I saw the same 7 we just had. It even went 8, 9. Or I saw 5 and I went 6, 7, 8, 9. This number string was written to help kids start to construct this idea that they could count on. It wasn't just about subitizing. It wasn't just about, let's just see how many there are, and that we're going to leave it there. This is really about, how can this idea help me be able to begin to start to count on in my understanding? Because I want them to start using that strategy. Okay? Any questions about counting on? Okay? Well, let's experience another number string. This time, though, we're going to use the reckon rec. So my question is to you, because I asked this question in grades 2 and 3, how many of you have used a reckon rec before in your classroom? Raise your hand. Okay, so we have some people who have used a reckon rec in their classroom. Okay, and we have some people in here who have not used a reckon rec in their classroom. So before we use a reckon rec, okay, I was assuming the people who didn't raise their hand. She's like, I did not. Tell me right now. No, I was assuming that the people who didn't raise their hand, y'all haven't used one. But since we have kind of a mixed room in here, and this kind of goes with the people who have used them, before I ever use a reckon rec with students, I always have them, the first activity we do with the reckon rec is just, what do you notice about it? Because there are some relationships on here that I want to make sure that people are start to see. Doesn't mean they're going to just hold on to them, but just looking at it, what do we notice? So can someone tell me something that they notice about this rec and rec? Red and white. So we have red beads and we have white beads. What else do you notice?
Groups of 5.
Where are the groups of 5?
5 and 5. Or, yeah, the red and then
5.
2 groups of the white.
So these red, this is 5, a group of 5, this is a group of 5, this is a group of 5, and that's a group of 5. Nice. What else do you notice?
Both the same.
They're both the same. What do you mean?
The top is the same as the bottom.
So this has the same amount as this? Does anybody want to elaborate more about that? There's 20 total. So there's 20 beads total. What else did y'all want to say though?
10.
There's 10. Where's the 10?
10 on the top, 10 on the bottom.
Oh wait, I heard 2 different things. So I heard, first I heard this one. There's 10 on the top. There's 10 on the bottom. But that's not what you were saying. So what were you saying? Where's the 10?
The red.
So this is 10 and this is 10. Yeah, it's kind of 2 different ways. Okay, so those are a lot of good relationships that we want to make sure that we're bringing out with our students, that they're seeing how this rec and rec is made up of. Okay? So, if you've never used a rec and rec, what I'm going to do is I'm going to pull the beads over here, and this is going to be our focus right here. So I'm going to ask you how many, and I'm going to ask you how do you see it. Those are going to be the 2 questions. And again, in a classroom, I'm going to make them signal me. For y'all, I'm not going to do that. The only thing I am going to ask is that when I say how do you see it, I'm going to ask somebody in the room to tell us how they see it. Okay? So here we go. How many? Y'all can tell me?
16.
16. How do you see 16? How do you see 16? Oh, so you looked over here, didn't you?
What?
I said focus over here. No, I'm just joking.
I'm
She's
that
like,
kid.
what?
I'm that kid.
No, it's her. If I really didn't want you to look over there, I would have put something
Okay.
over this, okay? So that's for you as well. If you don't want your kids to see what's over here, then put something. No, you did perfect. That was perfect. You did awesome. Okay, so you said 20 minus 4. Talk to me more.
There are 20 total, and you have 4 left to the right. So
So instead of thinking about 8 and 8, you're like, well, we know there's 10 on top, there's 10 on bottom. That's 20. And we're just going to adjust 4. That's kind of a nice way to look at 8 and 8 as 20 minus 4. Okay? Does anyone see it a different way?
Well, I saw
Wait, go ahead.
5 plus 3 first.
5 plus 3.
And then 8 plus 8 is 16.
Ah, okay. So you really saw this 5 plus 3 plus 8. It's kind of how you saw it. You saw it as 5 plus 3. You knew that was 8, and then you just added another 8. That's a way to see it. You want to see it a different way?
I saw 10 plus 6.
Where's the 10?
2 rows of red.
Ah, that red. That's kind of nice. If I know that these two reds are 10, and then did you just know that was 6? You just knew that was 6? Okay. So 10 and 6. And some people I just heard say, I thought 3 and 3. If a kid said that, I would write 10 plus 3 plus 3. Okay? Okay, here we go. Here's the next one. How many?
15.
Oh, we got a toaster. I may have to have us like, no. I told y'all could do that, but I got my toaster in the room. Like she saw it really quickly, and everybody else was just like, she just pulled it over there. It's okay. It's okay. I set you up for that. I'm sorry. I did not mean. Okay. So 15. Is that right? Okay. So how do you see 15? So you got that really quick. So I just want to know, how do you see?
I just saw the 8 plus 7 and I know my facts.
Oh, you know 8 plus 7. Okay. Does anyone else see a different way using the relationships that you see? chance. How many? 14. How do you see 14? Who would like to tell us, oh gosh, sorry. Tell me how you see 14. Who would like to tell us how you see 14? Up here. Somebody at this table. Who wants to tell me how you see 14?
10 and 4.
10 and 4. Where's the 10?
The reds.
The red. And then did you just know that was 4? Okay. Did anyone see something different? What? 7 and 7. So we already know that one? Okay. How many? 13. How do you see 13? Someone tell us how they see 13. I'm assuming you like that red, right? It's like, I am attracted to that red, and just, I know this is 10, I know this is 3, that is definitely a way to see it. I like that way too. Anyone else see another way to see 7 and 6 and know that that's 13? Anybody can see a double. Is there a double that you could use to help you with this problem?
6 plus 6 plus 1 more.
Oh wait, so I hear 6 and 6? And one more, you can see that double? Because I just heard someone say, kids like their doubles, right? So 6 and 6? Is there another double we could have used? 7 and 7. Isn't that the problem we just had up here? Yeah, we can use that, and then we can adjust that one. So if I know 7 and 7 is 14, then I just have to adjust one for 7 and 6, and I know that's 13. So 7 plus 7 minus 1. That's a really nice way of thinking about it. I can use doubles, which I just heard a lot of you say, well, kids just know they're doubles. You're right. Those doubles are ones that kids really latch onto. A lot of that has to do with there's lots of doubles in nature all around us, and so those are ones that we've made those relationships for. Okay. How many? 13. How many of you saw 13 because of 10 and 3? Did anyone see 13 a different way? Other than just knowing it. So 10 and 3. Did anyone see it any other way?
I watched you move it. I started doing it in my head.
You watched me move it and started doing it in your head.
I knew you were gonna start with 8.
Oh, you knew I was going to start with 8? So could you have a kid in your classroom who says, well, I did that, and so I knew that that was 8, and I went 9, 10, 11, 12, 13, 14, or 13? 9, 10, 11, 12, 13. Could a kid do that? Yeah, and if they did that, that's what I would do. Okay? And I would model that on there as well, as 1 plus 1 plus 1 plus 1 plus 1, so that I can see, to help them see how much work they did to do that. Okay? Anybody do anything else? Okay. So, what I find really interesting is that for a problem like 8 plus 7, we can use this double, this 8 and 8, to help us do something like 8 plus 7. If I know 8 plus 8 is 16, then I know 8 plus 7 is 15 because it's just 1 less. And it's really interesting on 7 plus 6. We can do the same thing again. And we could say, well, if I know 7 plus 7 is 14, then I know 7 plus 6 is just 14 minus 1. But some of you even also saw that in 7 plus 6, we could have done 6 plus 6. And then we just needed 1 more. That was really kind of interesting too. But really it's this idea that I can use that double, and then I can just adjust if I needed to. Now on this problem, as adults, we were really fixated on that red and that white. And if we haven't done And for our students though, they've done more number strings, they know they're looking at how numbers are related in those patterns. So don't be surprised if that's not the only way that comes out. Because kids will also start to see, oh, she's using doubles every single time. Like, what double could I have come up with here? What double could I have used there? Okay? And so this is what you just experienced. That was not what you experienced. Just a second. We're going to come back to this in just a second. No, we're not. I went too fast in my slides. I did another number string instead of doing that. Yes, we are. We'll come back to this just a second. That's what you just experienced. Okay? So, looking at what you just experienced, you did have 8 plus 8 and went to 8 plus 7. That was very purposeful. When this number string was written, I knew that for 8 plus 7, I had to find somebody in this room who did 8 plus 8 minus 1. When I got to 7 plus 6, for this number string, I had to find somebody who did this. Do y'all remember what I had to do, though, to get this to come out? Because y'all were really stuck on this. Y'all really liked this. Do y'all remember what I did?
You asked for doubles, didn't you?
I asked, didn't I? Did I tell you you had to use a double, or did I ask you? Do you see a double? Is there a double here that you could use? And if that still wouldn't have come out, I would have said, I wonder if you could use that previous problem, the 7 plus 7. I wonder if that could help you do 7 plus 6. And so I'm just putting that in the kids' heads to start to think about. Because that's what I want them to do. I just want them to start thinking about these relationships. And then what 8 plus 5 is what I call the clunker problem. It's the problem, it's a lot of times the last problem, I'm throwing it up there, I'm just going to see. What are kids going to do? Are they going to use a double for this? Because a lot of kids will, because they're going to start seeing the patterns, and they'll just use it. Some kids won't, and that's perfectly fine as well. Okay? Okay. So what you experienced, just real quick, is a number string, which is a series of related problems. That's really important about a number string. It's a series of related problems. They are all focused towards a strategy. The two you worked on was the strategy of counting on and the strategy of using doubles. But they're also about big ideas in mathematics. So in kindergarten, you don't have a lot of strategies because you're working on those foundational skills. For example, you're working on subitizing. So we have number strings that actually work on subitizing to help kids start to recognize those structures, to instantly recognize those quantities. We also have number strings that work on this idea of hierarchical inclusion, so that they're able to decompose numbers. Because what hierarchical inclusion helps kids see is that numbers are nested within numbers. So within the number 6 is the number 5, is the number 4, is the number 3, is the number 2. But we need kids to help them see that, because if they don't understand that, if they don't have that big idea of hierarchical inclusion, then it's really hard for kids to be able to decompose those numbers. So we have number strings that help kids construct this idea of hierarchical inclusion. Another big idea in mathematics is the idea of unitizing. So when kids get to their teen numbers, we have to get kids to understand that 13 is really 10 and 3, that 12 is 10 and 2, 15 is 10. That's the idea of unitizing. And so that big idea is a difficult idea. And so we have that big idea in kindergarten and in first grade to help them really understand this idea of unitizing. So we have number strings that really work towards big ideas in mathematics, not just strategies. In the older grades, we really focus more about strategies because y'all have laid those foundations for them. And sometimes it's more about the model. In K-1, you're not going to see that. You're always going to be using a model, and we're going to talk more about what those models are that you're going string is that it systematically nudges students towards efficiency. So, at the beginning in kindergarten, is it okay for your kids to be counting everything? Absolutely. But it's not where we're gonna keep our kindergartners. We're gonna nudge them, and we're gonna do number strings to help do this. But nudge them to see, oh, I don't have to count everything. I can start at this number, and I can count on, okay? Same thing in first grade. We're gonna get kids out of counting and help them start to see those relationships, that I can see 7 and 7 within 7 plus 8, okay? A big thing here is that the teacher facilitates by choosing who shares. So if you gave me an answer, I don't think anybody in here did though. Did anyone give me an answer and I didn't model it? Okay. So your kids are gonna be doing a lot of stuff in their head, so you're not gonna know what they're about to say to you. So if it's not something you wanna model, or if it's some crazy way that they're seeing it, and you're like, I do not want to model that, because that is gonna confuse everybody. This is what I say to my students. Say, good job, you got the right answer, but, good job. I'm gonna ask you more about that later. And I do go to them and ask them, and if it's really a good way, I will bring them back to share later on at a different time. But y'all know who those students are, who's gonna go off, they're gonna say some crazy thing, and you're gonna be like, well, I have no idea how to model that. That's okay, just say, good job. Did anyone do it a different way? You know what you're looking for, okay? Teacher model student thinking, that's really important. So you saw what I was doing up here, either what I was doing on those dot images, I was circling your thinking, or I was up here when y'all were telling me 8 plus 7, and you said I saw the 8 and minus 1, I did that so that people could see it. You're modeling what the student is saying. I also modeled it using equations here. In first grade, highly appropriate because y'all have the standard that talks about the equal sign, okay? You might not want to start here at the very beginning of the school year, but it definitely is where you want to lead them. So they understand that 8 is the same thing as 16, which is the same thing as 20 minus 4, which is the same thing as 5 plus 3 plus 8, which is the same thing as 10 plus 6. You want them to see what that equal sign really means. But here is what the power of number strings are. Pam Harris calls them problem strings. We're going to call them number strings. But really, the idea here is that they build relationships and connections in learners so that strategies become the natural outcome. I don't have to tell kids. Okay, guys, when you see 4 and 2, this is how you do it. You start at 4 and you go 5, 6. That's going to naturally come out because the string was written for it to come out. It's not going to come out for every single student in your classroom at the beginning, but if you do a lot of them, then people are hearing those conversations and they're starting to pick up on what you are modeling. Okay? Any questions about that? So, we are going to work a lot in kindergarten on counting. Okay? We're going to do a lot of things on counting. We're going to do a lot of things on some big ideas that help us with counting. And when we think about models that we're going to use, one of those models is the number path. So the number path, so in kindergarten, you are going to get a number path. And it looks just like that. It's like a pocket chart that you put together. And you're going to notice that the numbers 1 through 5 are in red, 6 through 10 are in white, 11 through 15 are in red. So we're going to follow this red and white pattern because it's going to help us transition to a rec and rec. And it's going to help our kids see the 5 and 10 structure within our numbers. But that is what you're going to use the number path because the numbers on there are going to help kids with their counting. It's not the only model you're going to use them. You're also going to use the rec and rec. So even when you are teaching counting stuff, you are going to use this rec and rec. At the beginning, we don't do quick images with the rec and rec because I want to give them opportunities to be able to see the beads and to be able to count the beads. But if you cover it up, you flash it, and then you put something over it. And your Rec and Recs that you are going to all get does have a cover that goes over it, which is really nice so that you can cover it, okay? The other models that you are going to get that are also good for counting are 5 and 10 frames and double 10 frames. They are already filled in with the dots, and so number strings have been written with those pictures already filled in. Okay? Any questions about that? So that is for that. We did this number string, which was more about getting kids out of counting and getting kids starting to see the numbers in those parts. So just like up here, when we see those numbers in parts, I'm thinking about this 7 now as 8, so that I can, I'm thinking about the 7 as 8 minus 1. Whereas over here, when y'all did 7 and 6, you were thinking of the 7 as 6 and 1, and you're reassociating that. That number string was really getting kids to start to think additively and pushing us out of this idea of just counting. So, what strategies do we do here? So using 5 and 10, that's what y'all love to do. So when y'all were doing this, and y'all were saying, this is 10, and this is 5, that's using the 5 and 10 structure. Because you're seeing that 5 structure in each one of those add-ins, or you're using that 10 structure of both of them put together, okay? Using doubles, I know y'all worked on that. Y'all may have called them doubles plus 1, doubles minus 1. We're just going to call them using doubles because I think you can use doubles for more than just plus 1, minus 1. Get to 10, then y'all might call that make a 10. 10 and adjust is something like this. If I had the problem 7 plus 9, kids like to think of 9, they know 9 is 10. It has a relationship to 10, so 7 plus 10 is 17, and adjust 1 is 16. And then there's some facts that really don't fall in there, and we just have to use other known facts to us to help us with those facts. Okay? But when we think of models, the Rec and Rec is a great model because there's no numbers written on here. So it helps kids be able to compose and decompose those numbers nicely. If you think about how kids can show you 7 plus 8 on the Rec and Rec, if I ask them to show me 7, they can actually just slide over because they can see that structure instead of having to do this. Now, that doesn't mean they're not going to do this, but they have the option of sliding that over. And so that's promoting that additive thinking about those numbers in those parts. The double 10 frames, the 5 frames that are already filled in are good for promoting additive thinking about the numbers in the parts. When you start computing and y'all are trying to get kids out of counting, do not use blank 10 frames and counters. And here's why. You can use filled in ones, but do not use blank ones. If I ask a kid to show me 8 plus 7 on 10 frames with counters, what are they going to have to do? They're going to have to count. Isn't that the very thing you're trying to get them out of doing? So don't do the very thing you're trying to get them out of doing with it. So you want to be very mindful of the tools that you're using for what your purpose is. If your purpose is about counting, like that conceptual part, then that is when blank 10 frames and counters are perfect because you're trying to get them to see those pieces. So remember that instructional approach, that conceptual piece, blank 10 frames and counters are great for that. But when you're trying to get them to construct strategies, you want already filled in ones because if not, they're going to count. Okay? And then open number line is another tool that is very abstract, but that's where that number path helps. So if they've had experience on the number path, the number path will help them with a number line. And notice that it's an open number line. You don't see all the grid lines, right? That's very important. Do not give them a number line with all the grid lines because guess what they will do if they see all the grid lines? They're going to count. want to give them an open one. Okay, any questions? Okay, so it is 2 o'clock, it's a little past 2, so we are gonna take a 10-minute break, and we're gonna come back and finish the rest of our time together, okay? So it's 2:04, we're gonna come back at 2:14.
Hey, it's good. How are you? Are you coming to the deal tomorrow? Yeah, I'm supposed to. I mean, Wednesday, yeah. Now you can be in specifically. They could do that in workshop.
Yes.
One of the kindergarten teachers like me a question, so she's talking about like composing and decomposing numbers up to 10. So she would cover this part, and would she like, let's say she's trying to do 7 and she's like that, and then what? How would you model that?
So it's always, if you were trying to show 7, then I would always either, so I would do this, and if you wanted to do 3 and 4, then I would do this and this.
Okay.
So you want to keep those groupings of the red
Okay.
together.
Okay.
That's very, very purposeful.
Okay.
Because it gives them that 5 and 10 structure of the number.
Okay.
Like, I don't want to break that apart.
I gotcha.
And so if I want to do 3 and 4, then it's going to be 3 and 4, or it's going to be 4 and 3.
Okay.
Does that make sense?
Yes, it does.
Yeah. And if you, it's a great question. And so in the number strings, we tell them how to model it. Yeah, it's told.
They didn't know they were getting them. They were all back there Googling like number strings. And I was like, no, that's what we bought for you here today.
I'll say that. I will say that so that everybody. Well, because I heard somebody go, I don't know these, and I'm like, oh, you're gonna get one. I
don't think they know.
Yeah, I'll make sure. I'll make sure and do that. which is so much better than me having to go, okay, bye. You know, good luck. Y'all are getting this stuff to be able to do this. So we're not teaching you something that you're not going to have the materials to do in your classroom. So any model, so those dots that you saw me do, you have a set of dot cards that have those exact dots that I just did. Okay? This rec and rec, you're getting this demonstration rec and rec. Even if you have one already in your classroom, you're getting another one. And this one, what you will notice is the box, there are hooks that can hang on your board so that they can hang up. Like I don't have those right now, so I'm holding it here. You do not have to hold it like this. But if you bring your kids down to a carpet and you sit on a chair, you can definitely sit it on your lap and do this as well. So it really just depends on what's comfortable for you. What else was it? The 10 frame cards and all that, you're getting all those. They're already filled in for you. We'll tell you which ones to use in a number string. That's already done for you. Okay? So you don't have to Google. You don't have to find these out there. Your district's already purchased them for you. Okay? Okay. So we've been working on the operation. First off, we've been working on just like counting on and composing and decomposing those numbers using those dot images. And then we moved into addition, looking at some ways of how that looks additively with addition. But what does this look like if we're trying to help kids with subtraction? So we do a lot of work with addition, but like, what does this look like with subtraction? So we're going to use picture images this time, not dot images, but picture images to help us out, okay? And so I am going to, I'm going to tell y'all that I have a flower garden, and your job is to tell me how many flowers I have in my flower garden. Are y'all ready? Here we go. How many flowers do I have in my flower garden? 8. So I have 8 flowers in my flower garden. How did you see 8 in my flower garden? How'd you see it?
6 and 2 plus 3.
Ooh, I heard 10 minus what? What did you say? 10 minus what? 2? So tell me about where in the world you got 10 minus 2.
10 frame.
Oh, so this looked like a 10 frame to you, and so it was missing 2 of those, so you thought about 10 and then minus 2? Oh, that's a nice way of thinking about 8. Okay? Did anyone think about 8 a different way? What's another way?
I counted it by twos.
You counted it by 2s. How'd you count it by 2s?
2, 4, 6.
2, 4, 6,
8.
8? Nice. See, let's see it a different way. See 8 a different way. 6 and 2. Where's 6?
The first.
So here's 6 and 2. Nice. Anyone see 8 a different way?
I saw 5 and 3.
5 and 3. So you see 5 on top. So I know that this is 5 and I know this is 3. So this is 5 and I know this is 3. That's a nice way of thinking about it. Okay? So here's my next image. But it has kind of a story about this one. So we know we have 8 flowers in our flower garden. I picked 3 flowers. How many flowers are in my flower garden now? How many? 5. How do you know it's 5? How are 5 flowers in my flower garden now? So you're saying there's 5. You take off the 3? So what do you mean? So talk to me. How do you take off the 3?
Mark out the bottom 3.
And so how does that help you if I mark out these bottom 3?
Because I know what a group of 5 looks like.
You know what a group of 5 looks like, and so you just need to remove 3. So we had 8, and we just removed 3, and I could either remove that whole group of 3, and if I did that, it would leave me with 5. Is there another way to do that? How else could I have done that? Yes?
I marked off 3 at the top.
Oh, you marked off 3 at the top. Which 3 did you mark off at the top? Right here?
Yeah, the end.
Oh, you see 5? What did you see, 5? One group of 5. So some people are like, that's just a number that when I see it, I just know that that's 5, right? And that's perfectly fine, because that is a small enough number that you can subitize that. That's about the limit, though. After 5, we really decompose that number into parts, whether we know we're doing that or not. But after 5, you get up to larger numbers. You're really taking that number and you're decomposing it into different parts and putting it back together. But you don't recognize maybe that's what you're doing when you're doing that. Okay? So the next question, though, is, so if I have 5 flowers in my flower garden and I picked 3 of those flowers, how many flowers do I have in my flower garden now? 2? How did you do that? How do you know you have 2? What'd you do?
I just, if I take 3 away, 2 plus 3 is 5.
Which 3 are you taking away?
I took the last 3 away.
So you took these last 3 away. You're like, I'm going to take those last 3 away, and I know that's 3, right? And then so I'm left with 2. So I had 5, and I took a group of 3 away, and when I did that, I was left with 2. Is 5 made up of 2 and 3? Yeah, so I can see that if I think of 5 as 2 and 3, I can just remove that group of 3, and I'll be left with 2. So thinking of 5 as 2 and 3, that's kind of a nice way of thinking about it. So I can do that one. Okay? So I had 3 flowers in my flower garden, and I picked all of the flowers. I picked all 3 flowers. How many flowers do I have left in my flower garden? 0. Okay? And so my question to the kids would be like, well, how do you know? How do you know that's 0? If you have 3 in your flower garden, how do you know that's going to be 0 if you pick 3? It's what?
It's all of
Because it's all of them. And so this is 3 right there, right? So if I go 3, 2, 1, that's going to end up with, I'm going to be at 0. So 3 minus 3. Okay. Any questions about that? Okay. So this is the number string that you did. Y'all didn't do a lot of counting back in here, and that's okay. But you can see in here that we give you the context. So if you look at 8, it says, teacher, I have some flowers in my garden. How many and how do you see it? I needed somebody to tell me that they saw it as 5 and 3. I really needed people to see it as 5 and 3 because I knew my next problem was going to be 8 minus 3. I needed you to see where that 3 was. The same thing on the next one, on the 5 though. A lot of y'all just know that's 5, but if we understand that it's composed of 2 and 3, that can also help us with that. And then we have our 3 minus 3 there. Okay?
So if our children don't count back, do we need to?
Well, it would depend on where your kids are. So I would say that when your kids are, y'all don't count back because y'all are adults and things. But if you think about initial instruction and how kids are able to get to that answer, most likely a lot of them there'll be somebody in your room who will do it. You just have to find that kid in your classroom. Okay? Let's try a different one. Oh, no, let's have a partner talk here. What was different about this number string than the 2 previous ones we had done? What's different about subtraction? It's a little bit different than when we did addition. So talk to the people next to you.
So did you find the addition more complicated?
I will tell you that when we did our testing and subtracted my students to do it, but because they wanted to do it out without pictures, they couldn't do it. have two drinks, and if I give one away, I mean, make it pay too. But when it's the addition, for them to have to say, okay, this is how many I already have, you have just two pictures up there, and someone gives you more.
So
They
they
can,
have to visualize
that one more coming in, and that's more, they don't get it.
I mean, some things you just assume they know, they don't.
Just like separate big amounts. Yeah. Because it's easier to take it away. Because you can, you're physically, I don't know, it's just different to me. You're physically taking it away. And it depends too on your habits. Because we were always, you're eating something, or you're giving someone something, or you're.
Most of mine are crockpots. You didn't use that analogy this afternoon, I thought.
I thought I did at the beginning, right? Yeah. Okay, yes.
I get the crockpots.
Okay, finish the sentence you're on. So, tell me, what did you, what's different about this when we're doing subtraction? What makes this feel a little bit different than when we did addition? What's some things that you noticed? Heard y'all talking.
I think the pictures made a difference.
Okay.
And to me, I think that they understand taking away when you have something, when you have a visual. I don't know if that makes
Yeah.
sense, but when you have that and they can, in their mind,
They
pull that
can
away
pull that away.
and see what's left.
Okay, and so that was helpful. Was it helpful the way it was arranged? So like when we did 8 minus 3, was it helpful for it to be arranged in 5 and 3? Was that purposeful?
Yes.
Yeah, it was very purposeful. So thinking about that, like we arranged these pictures on purpose because I want kids when they think of 8 is think of it as 5 and 3, especially when they're removing 3. Because that would be really nice. They can just remove that 3 and they're left with that 5 that they're so familiar with. Okay? So that was very purposeful. What else? What made it, anything that made it different?
I just think subtraction is a harder concept
Yeah.
for some of the kids than addition. I think addition's much easier for them to catch on and figure it out in their heads and stuff like that than it is.
Okay.
They're not used to counting backwards.
Mm.
Everything's counting, 1, 2, 3.
Everything's counting, and counting forwards is much easier than counting backwards. And if you don't believe that, then I want you to start at R, and I need you to go back in your ABCs right now. That's what our kids feel like when they do numbers. When we ask them to count backwards, that's exactly how it feels. If I start at R, I need y'all to say the alphabet backwards. That's what it feels like for kids who are just learning to count. And then we say, oh, you just have to count backwards. You go 20, 19, 18, 17. Yeah, for us, it's really easy, but we've been doing it for a long time. But if I ask you about the alphabet, y'all are like, oh, no. I mean, like, I have to really sit there and think, well, that's what kids have to do. So counting backwards is not something that's really easy for kids to be able to do. So that makes it a little bit different. But I think something else you said, why would this, like this subtraction, not be as intuitive as the addition? So let me give you an example. On the addition, I showed you in the dot pictures, the first problem was 4, and the next problem was 4 and 2. And that was a whole lot easier to use that 4 and just go 5, 6, right? Because what happened to the picture from one to the other? Part of it was the same and part of it was different and I could see it. In subtraction, what's the picture look like that I gave you? The exact same picture. I did nothing to that picture. I didn't put any together, I didn't chop off any, I didn't do any of those types of things, did I? So that makes it feel a little bit different in a numbers string because you can't model both of the pieces in the subtraction because the kids have to actually model part of that, right? Because that's part of the subtraction. So that makes it feel a little bit different as well. So I just want to bring that out because that's going to be important, especially for the next number string that we're going to do, because we're going to do a subtraction one again, but this time we're going to use the rec and rec. And you will notice for me, when I do this, we're going to cross our fingers that I do this completely smooth for y'all too, because I sometimes when I'm looking at my string, like I have it right here, when I'm looking at on this card, I end up making the same mistake, you know, as far as modeling both of these numbers, and I'm not supposed to, okay? So I'm just letting y'all know, I'll be really honest, like that's, it's just different, but it can be very powerful for your kids. So, okay, so here's the first one. Okay. So here's the problem. Problem is 11 minus 1. What is 11 minus 1? Who would like to tell? Y'all can tell me? 10. How do you see 10 up here? How do you see 11 minus 1?
Just pretend it's not, it's like it's not down there and what's left is 10 at the top.
So if I just remove this 1, yeah, so here's 11. I can just remove this 1, and that gets me to that nice 10 because this is really nice to see, right? So I can just get rid of this so I can just see that 10. So 11 minus 1 we know is 10. Okay. What about 11 minus 4? I wonder if you could get to that 10 first, and that might help you. Because y'all said y'all really like that up there. To help you with 11 minus 4. So what is 11 minus 4? Oh, sorry. What is 11 minus 4? Y'all can tell me. 7. How do you get 7 from 11 minus 4? What did you say?
I would stop the bottom and back over.
Okay, and that gets you where?
10,
Okay.
and then I write in 1, so I need 3 more.
So could you just remove the other 3 from that 10? And then you would have how many?
7.
7? That's really kind of nice. So for 11 minus 4, I could just remove that 1 to get me to that 10. And we've done a lot of work with partners of 10 in our classroom. So now we just have 3 more. So I know if I remove the 3, I should have how many left? 7. That's a really nice way of thinking about it. It's 11 minus 1, that gets me to 10. 10 minus 3 gets me to 7. Nice. What about 15 minus 5? What's 15 minus 5? Okay, tell me. 10. How do you know 15 minus 5 is 10? Can I just remove this group of 5? And that gives me that nice top row, and then I just know it's 10? Nice. Okay. What about 15 minus 6? What's 15 minus 6? What's 15 minus 6? Who wants to tell me? Y'all can tell me. 9. How can you get 9 for 15 minus 6? What do you want me to do? Say it out loud. You're saying it to yourself. Say it out loud for all of us. What do you want us to do?
Take away the 5 and then the 1 and 1 up.
I could take away this 5, which gets me to 10, and it's 6, so I just need to take away 1 more, and then I'm left with 9. It's really kind of nice to think about 15 minus 6 as really 15 minus 5. Well, that's 10, and just 1 more. That's 9. It's a really nice way of thinking about that. So getting to that 10, really nice. Okay? What about 13 minus 5? What about 13 minus 5? and so 2 and 8, so I know that have 8 left. That's a nice way of thinking about it too. Nice. So I could take from 10, or I could get to 10. Those are 2 different strategies, but really good strategies to use for something like this. Okay? So that is what this one was, a strategy for get to 10. So it was very purposeful that the first problem I gave you was 11 minus 1. I needed you to see how nice it was to see 10 on top. And y'all saw that. When you removed that 1, you were like, yeah, I believe she just with that 10. And then 11 minus 4. I had to find somebody in this room who noticed that you could just take the 1 from the bottom, and then you just had 3 more from the top. And that's really working at partners of 10 at this point, because now we have 7 left. 15 minus 5, same way. 15 minus 6, I gotta find somebody who's taking that 5, and then taking that 1. And then the 13 minus 5, you were perfect, because remember, this is not always for every single one in your classroom to do the exact same thing on that last problem. It still is about that creativity that I want to give them options in how they see it. And she saw it from the top. And that is perfectly fine. Was it what I was necessarily going for? No. But is it a good strategy? Yes. And that is why I modeled it. Okay? Because we actually have number strings that are written for that exact strategy.
So the same thing, if you would have done the same thing with 11 minus 4,
Mhm.
because you could have chunked 4 white ones over and then left that red one down at the bottom. It's not as smooth as the 13 minus 5.
Right. And I want them to see that. And we might could have a conversation about that. It's not as smooth. Does it get you the right answer? Is it where I want to necessarily leave them? Probably not. Because when I take from 10, I might want to take this whole 5 away, or I might want to take the 6 away. I mean, I might want to do something like that to leave me with those 2 things. But, I mean, could you do it? Yeah, you can take from 10, or whatever it was. Okay? Not as smooth, but you can do it. And some kids can do it. Okay? Any questions? Okay. So, we do number strings. The main reason for number strings is to help kids construct strategies. Remember at the very beginning we talked about numeracy, and we said that numeracy can't be taught, it has to be caught? Number strings, I knew that was about to happen. Number strings are how we get kids to catch numeracy. Because I don't have to tell them, this is how you shall see it. I help bring that out. Other kids start to see it, and eventually we're starting to construct our own strategies and have those conversations. Okay? So once kids have strategies in their pocket, then we can have a really good math talk. If everybody is seeing things the same way, so if everybody sees 4 as just 4 and doesn't see it as anything else, your math talk is going to be really boring. I need people to see 4 as 2 and 2. I need people to see 4 as 3 and 1. That's going to give a rich math talk. Okay? So we do number strings so that we can bring those ideas out for those students so that they know that there's different ways of looking at those numbers or those operations. So this is going to be our math talk that we're going to do as a group. So here's our math talk. It's one problem. I want y'all to solve 5 plus 9 plus 6. Okay? And if you need to keep track of your mental steps on paper, you can. You don't have to. But what is 5 plus 9 plus 6? So take a moment to do that. Okay? Who would like to tell us what's 5 plus 9 plus 6? 20? Okay? Did anyone get something different? Okay. Who wants to share your way of figuring out 5 plus 9 plus 6?
Take 1 from 6 and add it to 9 to make 10.
Okay.
And then it's 5 plus 10 plus 5.
Ah, okay. So 5 plus 9 Nice. So you still put those 5, you regrouped, you reassociated those, and so you got the 10, and then that will give you the 20. That's a nice way of thinking about it. So you saw something about that 9, and you're like, ooh, I can make that 9 a 10, and that would be much friendlier. Okay? Did someone do something different? How did you do it?
9 plus 6 is 15 plus 5 is 20.
Oh, nice. So you said, I'm not going to go from left to right. I'm just going to find chunks that I know. And so you said, I knew 9 and 6. I am not asking kids to use parentheses, but I'm modeling her ideas. Those are grouping symbols. This is how she thought about it. She thought about it as 9 plus 6, and then she just had 5 more. And 15 plus 5, was that a nice way for you to think about it?
Yeah, so it's counted by 5.
You just count by 5s. Nice. Okay? Did anyone in here do it a different way?
I did 6 plus 5.
You did 6 plus 5? So these two numbers talk to you? So you kind of
It was 11, and then I put the 9 with that 1 to make 2 groups of 10.
Nice. Okay. So you did 6, you said you did 6 plus 5. You knew that was 11. And then you had 9 here. And then what did you do after that?
I added the 9 plus that extra 1 to make another 10.
This extra 1.
Mhm.
So you kind of took that and you gave that, and so then that's 10 and 10. Which is nice. Yeah, that's a nice way of thinking about it as well. Anybody do it a different way?
I just took I took 1 from the 5, because I knew 6 and 4 was 10, and 9 and 1 was 10.
So you did it similar to this one.
But
But-
I always go back to the left.
Oh, but you like the left and the right or whatever.
Yes.
So you said, I'm going to take 1 from here, and you're going to give it here. So then you were left with 4 plus 10 plus 6. And then what?
I knew that 6 and 4 was 10.
So you knew those partners of 10 like that, and so there's that, so 10 plus 10 is 20. It's a nice way of thinking about it. Another nice way of thinking about it. Look at all those different ways in this class, in this room. We're all thinking about those numbers of 5, 9, and 6. Y'all all saw those relationships and are seeing them just a little bit differently and how they speak to you. That's exactly what a math talk is. It is one problem. That's it. I pose a problem to my students. I'm looking for multiple students to share different ways so everybody can hear how everybody was thinking about it. I can compare those strategies. So you heard me say right here when we were comparing these. So those are similar. Well, how are they similar? Well, they're both making the 9A 10, but they did it in different ways. Those ways, though, were really similar. We discussed this idea about efficiency, clever, and elegant strategies. This is where we really talk about, well, so we didn't have anybody say that I started at 5 and went 5 plus 9 is 14, and 14 plus 6. And I know some of us may have done it because we are trained to look from left to right. But when y'all heard some other people's strategies, you're like, oh, yeah, if I would have found those partners of 10, that would have been really kind of nice. Okay? But it's about having those discussions. But this math talk is about focus towards choosing a strategy. So remember what I said about numeracy? We need to give kids opportunities to look at numbers and decide what's the best strategy for those numbers. Math talks allow kids that time. Number strings are not. Number strings are about constructing those strategies. Math talks are about allowing them the time to construct, to choose a strategy from already constructed strategies. Okay? So let's look at what a first grade classroom with 7 plus 8 might look like. It is not a full-blown math talk, okay? So it doesn't have the teacher posing this and doing it. But what I'm going to show you is, these are first graders at the end of first grade who had done number strings and math talks in their classroom. They had lots of discussions. They used models like the Rec and the 10 frames and things like that. And so what we're going to do is we're going to see how would kids do 7 plus 8 at the end of first grade, okay? How might they choose to do it?
Okay, 7 plus
3, and that's 15. So she is seeing this. She's seeing those numbers decomposed into those 5s. Okay?
What is 7 plus 8?
15.
How did you get that?
There's the 8 and the 7. There's 2 from the 7. You take the 2, put it with the 8, and there's a 10.
Yes.
And there's 5 more. And then there's 2.
Did y'all see his hands? So he doesn't have anything in front of him, but he's doing what he's seen as teacher model a lot. So he says, I can take the 2 from the 7 and give it to the 8, and now I've got the 10 and the 5, and that's 15. So this is that idea of getting to 10. And let's watch. Over double and then get to 10 and then have a math talk. Stay on the strategy. Let them really take ownership of that strategy, okay? When you see a lot of your kids starting to take ownership, then what I might suggest you do is you make an anchor chart of that strategy. When you see a lot of your kids really starting to use this doubles idea, then I'm going to do a math talk like 7 plus 8, and part of that would be focused on, oh yeah, we did a lot of this doubles. Let's make an anchor chart so we can solidify this learning and we can post it up in our room. Now they're going to have a chart that's going to anchor them to this idea of using doubles. Okay? But when you're thinking about math talks, you're not going to get to this point where you're going to have a ton of different ways until kids have started taking ownership of those strategies themselves. Okay? Okay. So what we've talked about today are number strings and math talks. And here's the big difference. Number string is a set of related problems designed to teach strategies based on relationships. That is really important. It's not just strategies for y'all in kindergarten. It does the big ideas, but it's all based on the relationships of the numbers. Whereas in a math talk, it's more designed to give kids opportunities to tell us how they see the numbers. What strategies are they thinking of? And really talking about those different types of strategies. Both of them are meant to be 10 to 15 minute routines. They are not meant to be any longer than that. Okay? And that's important to note as well. 10 to 15 minutes only. At the beginning, sometimes it does take a little bit longer, but my suggestion always is, like, set a timer. At the end of 10 minutes is the end of 10 minutes. Start that string the next day if that's what you have to do. And that's okay. Okay? But here's what's important, is that both of these things really work together. You can't have a good math talk unless you've helped your kids construct strategies. Okay? So they both work together. So what we're going to do next is we are going to talk about daily math fluency, because that's what you're going to get. That's going to have these number strings, that's going to have the math talks. So what we're going to ask y'all to do, Tony, do you want to do this, or this part to give them the boxes, or do you want me to tell them how? Yeah. You go ahead.
Okay, so here's
You're in charge.
You're gonna get your boxes. So here's, kinder is right here, and first grade is over there. You'll see a label with your school. So get one from your school, because we count
representing a campus, we're gonna get all your teachers' boxes, put their names on them, and go ahead and put your teachers' boxes over at their school. But you go ahead and open your box, and what I want you to get out is going to be this case right here. So in every box, there's this case. There's other things in there, but inside this case are gonna be your number strings and things. I want you to at least have this case sitting on your table, and we are gonna go through the contents of your box together, okay? So I'm gonna give us about 5 minutes to get our boxes, get our names on them, get them separated, and get this out, and then we'll come back together and we'll go through your box, okay? You heard me talking about unitizing and things like that. If those are not words that you are familiar with, or you're like, I'm not real sure what that is, when she was saying this, those strategy names in Big Ideas are over here in that column. They say the name, then in the middle, we've made a written explanation of that strategy or big idea, and then we've shown you with a model or tool what that looks like, how that would be modeled. On the very back page, it tells you what models are going to be used in your grade level. So you should see, like, the picture and dot cards. You should see the 10 frame cards. You should see a reckon rack. You might see an open number line. But those in the teacher guide, those are the most most important pages in my opinion, okay? Because that's going to familiarize yourself with what you're going to be seeing on the number string cards, okay? Then, you have a tube in that deal, don't get these out, but there's charts in there. All the charts have on them are the names of the strategies or big ideas, what you're working on. My suggestion to use on those is, if you're going to use those in your classroom and hang them up, cover them up, and as your kids have solidified a strategy, then you can reveal that strategy to them. Okay? I would not just hang it up and just have it something in there. Make it very purposeful and meaningful to them. Oh yeah, so okay guys, I really think we've got this idea of using 5. So now that's a strategy that we can say that we have and that we own. The next thing are the number string cards. So you should have 2 sets of number string cards. Inside there is a clip, a hook that looks like this. Is it already done?
Yes, they are already ready. Yep.
Well, I haven't gotten a set that they're already ready for. That's amazing. I've had to put mine in there, so that must have been something changed. That's good. Okay, so 2 sets. 1 through 30. Cards numbers 1 through 60, and then cards 61 through 120. If you want to know what strategies cards 1 through 60 have, it is on the front page right at the back. It says contents. It tells you what strategies are on what card numbers. Okay? People have asked me, were these written in a certain order? Are they intended to go card 1 through 120? The answer to that is no, or are they intended to go from 1 to 120? The answer to that is no. Were they written in a certain order? The answer to that is yes. So did I think about what types of things do kids construct first and things that build upon each other? Absolutely. But this is not intended that you have to go card 1, card 2, card 3. You might do a few from one strategy, leave a few from that strategy, go to another strategy, do a few, and then later on in the year you can bring those back in when you start seeing that kids are reverting back to something. So it's intended, you have 120 number strings, and you have 60 math talks. That's enough for 180 days of instruction. Guys, we know, you're not doing a number string and math talk every single day, 180 days. You've got other things. You've got field day, you've got assemblies, you've got all kinds of stuff, okay? But we've given you enough content to fill up 120. You have a math talks book that looks like this. This is going to be your book that has those 1 problems on there. We'll talk more about that, but this has the sample, the problem that you would post, just like I did up here when I did 5 plus 9 plus 6. It gives you those problems. We'll talk more about what's inside it in just a minute. Okay? And then you have all your demonstration manipulatives that you need. So, let's talk about the number string cards. Our suggestion for number strings are that they be done 3 to 4 times a week. That's kind of the idea behind it. It is a 10-minute routine only. But this is what your card looks like. So, at the top, we identify what strategy you're trying to construct with your students. This is an example of using doubles. Over here on the left, we tell you this is the problem that you're working on with your students. And we even say, show 2 on top, show 2 on bottom. And you can see it over here in the picture. You will know what tool to use because you will look over here on the right-hand side of the number string card. If you see a reckon rack, you're using a reckon rack. If you see something else, you're going to use that tool. You see a number path, you're using a number path. It tells you right there in the middle what questions to ask. So, I asked you questions. So this one would be, how many beads? How do you see them? And the goal that you see on here is always going to be the goal that's associated with the 2 and 2 is, or that's a double that I know, or something like that. Does that make sense? Okay. So it tells you what you're looking for. And over here, it shows you how to model it. You have a choice, guys. This is just suggested to you. This is what it can look like. You do not have to do that all the time, every time. Okay? But we've given you that. Every grade level is just a little bit different. You can see that in K and 1, you'll have the same demonstration manipulatives, except for in grade 1, we do go into an open number line, and we do start using more of equation style type things. That's really the only difference, though, as far as manipulatives go. Here's the Math Talks book. We say Math Talks come about 1 to 2 times per week. So number streams are 3 to 4 times. That's why you have 120 of those, and you only have 60 Math Talks. So we're only going to do those 1 to 2 times a week. It really is about eliciting the various strategies. I can tell you at the beginning, those Math Talks may not be real rich. You may only hear a couple of different ways, and that's okay, but it tells you where you need to go in your number strings. Okay? It is also a 10-minute routine. So inside the Math Talk book, what you will see is at the top, that's the problem you're writing on the board. So you're going to write whatever problem that is on the board. And then what we've done is we've provided you 4 different strategies for that problem. That is not an exhaustive list of strategies, but that is 4 strategies that we could see, that we would want to see in the classroom. Okay? And so those are identified right there. We've even shown you how to model them on different types of models. If a kid didn't use a reckon rack, but you don't think that everybody in the classroom is following what that kid is saying, you might want to get a reckon rack out to model that kid's thinking on it, even if they didn't use that. Okay? So you have those. The last one, the 4th strategy that we give you, we just don't give you a way to model them. Okay, it's just something, we only modeled 3 of the 4 strategies. In the classroom, you can model all of them. We also give a teacher notes section. So if you just want to know, well, how am I supposed to start this? We tell you, start the Math Talk by writing 5 plus 3. Give students time to think mentally about it, then ask them questions. We've also provided facilitating questions for the Math Talks. Those do not change, but what over there in the teacher notes of how to start it does change. Okay? So these strategies aren't something that they're gonna see in your grade level and never see again. They're all strategies that continue to build upon each other and will transition very nicely when they get into 2nd grade with multi-digit addition and subtraction. So just kind of keeping that in mind. In kindergarten, we're not going to go into use 10 and adjust. We're not going to go into using known facts, but we are going to really work on counting on and counting back. We're even going to do some work with doubles because we know that our kids can construct those ideas of doubles. That's going to help our 1st graders. And so these are the strategies for 3-5. I should have taken this out. And the last thing I want to share with you, though, is we've also created a sample lesson plan. But you get the sample lesson plan at handinmind.com/dfluency. If the D does not work, like if you put the D in the fluency and that doesn't work, then just put fluency, and it will work. And you're going to download the guide. Inside the guide, we've given you 4 weeks of what it could look like in your classroom. So we've taken number strings and we've shown you, like I would choose these number strings and I would choose this Math Talk for that week. And at the bottom, we've given a notes section that tells you why we chose that. So you can look up there, it says, number string 61, 62, and 63 are used to begin working on constructing this, and then I would move to this Math Talk because I'm trying to see blah, 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 blah. But we've done that for every grade level. So kindergarten, you have a 4-week plan. 1st grade has a 4-week plan, just like that. Okay? If the D does not work, Just take the D off. But where this is gonna be found is in the guide. There's a guide that you're going to download. So this was kind of an afterthought. We kind of got a lot of questions, how do you plan these? And so we created this document for you. Okay? Any questions for me about what you have sitting in front of you?
Where are the charts?
The charts should be in a tube. There's this tube right here. Yeah, that right there. That tube right there. The charts are in the tube. Good question. Okay. The other thing I want to say is in the picture in dot cards, something, I'm going to go back to, not that, I'm going to go back to our string that use pictures in dot cards. Sorry. Okay. Your picture cards have a label at the bottom. Okay? And it says, picture card, show card P-N. So if you look at your picture card and you look at the bottom, there's going to be a card that's P-N. Okay? Then for the 5, it's P-M. So you're going to have those cards already ready for your kids when you do that. Okay? Any questions? I just want to make sure that's clear. That's the same way the dot cards are. It's the same way the 10 frame cards are as well. That's how you know which ones. We tell you which ones you're going to use. So I can go back to those dot cards. Oh, right there it is. So show card D-E. Show card D-N. D-M. Okay? So that's how you know which ones to pull when you're going to do that number string. Okay. Do y'all have any questions for me? Okay, y'all have been wonderful. I'm going to give y'all my email address as soon as I get to the very end of this. And when you get back to school in the fall, if y'all have any questions, comments, concerns, please let me know. And I will always be there to help y'all do whatever you need, like implement or whatever. Because we want to make sure there you go. Goerig@handofmind.com. So please feel free to write that down.